Hi, this is Brian Kim. I'm going to share with you case number 116, the best way to do cataract surgery series. This is a 3 to 4 plus dense lens. You're going to see terminal chop, cross chop, mechanical fracturing, and reduced CDE by using mechanical forces to crush the lens pieces. And as a result, clear corneas postoperatively, which again implies less corneal endothelial trauma and damage. And that's because I'm mashing the pieces together using mechanical forces rather than using high levels of ultrasonic energy to break up the lens pieces. So I'm using a cotton tip to steady the eye and using a corneal marker, which will help me to center and size Rhexis. Using that cotton tip, I'm holding the eye and turning it to the left, which allows me to create a nice flat approach for my corneal incision, my paracentesis incision. And I do the same thing on the other side. Again, I'm asking the patient to look that way, and then I'm fixating and immobilizing the eye with the cotton tip. But using the cotton tip, it's just an atraumatic way to control the eye without having to grab it. This is some intracameral lidocaine and then some intracameral epinephrine. You can see this patient squeezing a little bit here. This is some dispersive viscoelastic to flatten the anterior capsule and to coat the corneal endothelium. There's a little bit of pooling of fluid as well in this patient. Again, all of this we have to navigate through. Every eye is different. Every eye has different challenges. So because this patient's squeezing some, I'm using the cannula to hold the eye. And this is the triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove tunnel. You can see I'm using the cannula to turn the eye away from me and to control and immobilize the eye. And once I'm ready, I go ahead and enter. And quite a bit of oily material is being liberated with the patient squeezing quite a bit. So I'm asking for my assistant to flush the eye periodically here. So I'm using the sharp tip Haldi Percars, puncturing the center, pulling down toward me, grabbing the right side of the tear there, which creates a nice flap. Again, I made the length of that tear to match the corneal mark that I made, which will hopefully allow me to have a well-centered and sized Rhexis. You can see these thin profile Rhexis forceps are very nice. Good control, minimal radialization forces during the Rhexis, and no corneal distortion with this maneuver and this forcep. Burp some viscoelastic out, and this is there's actually an eyelash being exposed here, and so I'm going to go ahead and cut that eyelash. More flushing. Again, this patient's squeezing quite a bit, and I bet during the draping she squeezed, which enabled some of those lashes to get out. This is a Capsulorhexis hydrodissection technique. I place a cannula under the Rhexis edge, contra-incisionally, get a nice wave, decompress on the left side, and then sweeping on the right side, hooking the peripheral lens, and the lens begins to spin. Sweeping some more on the left side as well. Just try to loosen the lens up as much as I can. Irrigating the surface of the eye. You can see how much this patient reacts every time water gets in the eye squeezes down. Lifting the incision with the chopper, going in with irrigation off to minimize Descemet's trauma. Removing the surface epinuclear material here. And again, this is a fairly dense lens. I'm going to go ahead and proceed with terminal chop. I like terminal chop because I'm able to debulk the center, and it also creates some space, which is really nice in this situation. So I go ahead and sculpt mode. Go ahead and sculpt the little trough. And again, with this trough, I don't go all the way to the periphery. There's really no need. You want to debulk the center core, the apple core, so to speak. So I place a chopper around the lens, and then I fracture that terminal side, and I'm able to use those forces of cracking to propagate the chop all the way through and through. Place a chopper around the right heminucleus, and then pulling it centered toward the fingertip, and then it fractures. You saw that loss of resistance every time I pulled that chopper toward the fingertip with the terminal chop and cross chop. It causes that loss of resistance, like you're cracking a knuckle. You can almost feel the tactile sensation of fracturing that lens piece. And that's really the power of mechanical fracturing techniques, is utilizing and leveraging mechanical forces. And by doing it this way, you're really using less ultrasonic energy throughout the case. So I got that chopper around that first quadrant piece, trying to fracture it more in half, lifting the pieces up out of the bag using the chopper and hooking the peripheral lens, and then mashing the instruments against the lens material and emulsifying the lens piece. So this is the second quadrant, and we do the same thing, putting that, you saw that loss of resistance right there. I had the phaco tip deep between the lens pieces, was able to place the chopper around the lens at the equator, and then pulling it centrally toward the phaco tip, and then fractures. You saw that loss of resistance when I'm fracturing. Very well controlled, very systematic, very easy to be able to tackle each piece one by one. And it all boils down to being able to confidently position that chopper around the lens. When you're going after the lens pieces from the center and from the top, it's very inefficient because you're trying to suck the lens piece towards you. And it's not really, sometimes it doesn't want to do that. And so by getting around the lens, you have opposing forces on either side. You're flanking the lens piece on both sides. It's much more efficient and also therefore much more safe in a lot of ways, because you're not going to get frustrated. You're not going to do something that you shouldn't really do when the lens is stuck and not coming towards you. So here the lens is not turning very well, and I have the left heminucleus here. So we're going to try to figure out how we're going to turn that lens. Yeah, just very gently. You can see peripheral forces just tapping it, and it finally turns here. So again, don't use forceful rotational movements on the capsular bag. The zonules will be suffering when you do that. Placing the chopper around the lens piece, pulling it centrally toward the phaco tip. And again, you saw that fracturing and sudden loss of resistance with each of these fracture points. So again, throughout this case, you can see the compression force that I'm applying, and suddenly, boom, that loss of resistance. And you saw that the instruments had that loss of resistance when it cracked and fractured that lens piece completely in half. Again, that's a testament to the technique. And you have to learn how to position the instruments around the lens piece. That's really the kind of the other learning point when you're doing this technique, that again, unless you're doing the technique, you really have no idea what I'm referring to. You have to position the instruments around the lens piece, exactly opposing each other. So when you bring the instruments together, it fractures it. If you don't have them exactly across from each other, when you try to bring the instruments together, it might not crush it, and might just kind of rotate the lens piece. And so all of that has to do with just technique, experience, knowing how to position the instruments. And again, you can do the chopping and fracturing from any angle. And that's really the advantage of this technique. You never feel like you're oar-locked. You never feel like you're handcuffed. You have very good control, and it's very versatile. I push some more viscoelastic in to protect the corneal endothelium. You can see I have this loose piece here, and I'm able to just position the lens piece so that I can get the instruments around it, and then I just go ahead and crush it. Once you crush it, use some vacuum to grab some more pieces, and then using the vacuum to hold the lens piece on the tip, and then getting the chopper around it, mashing the lens piece into smaller pieces, and then just carefully emulsifying the lens piece. So again, this is a pretty dense lens. You see the CDE is approaching 7 now, but again, it's not in double digits. It's nothing like it would be if you're doing, divide and conquer or traditional chop techniques where you're having to sculpt troughs and crack and sculpt and crack and sculpt and crack, or you have to lollipop the lens and then chop and lollipop the lens using ultrasonic energy. This is really a much more efficient way, in my opinion, to be able to fracture the lens pieces into smaller pieces, and you feel good about it because you're not using as much energy, and as a result, hopefully more likely clear corneas postoperatively. So I take the chopper out, push BSS in, take the phaco tip out and go in with the INA handpiece. I start sub-incisionally always because, again, the cortical material and sometimes epinuchal material is keeping the capsular bag concave. You can take advantage of that, and you want to go after the sub-incisional material first. It's really the easiest at that time. And start to remove the rest of the cortical material that's there. You can see it's quite adherent when I'm doing the maneuvers here. And you want to be patient. Remember, the machine is really quite powerful. You have to modulate how much vacuum you use in this situation. You don't want to grab the bag or the zonules. So go ahead and switch to polish mode and polishing the posterior capsule as well as underneath the rhexis edge. You always want to polish underneath the rhexis edge to remove all those lens epithelial cells. Go ahead and pulse the subincisional capsulorhexis here, which looks pretty clean. Injecting some cohesive viscoelastic to fill the bag. And then using the sweep to polish the rhexis edge on the left side and then the right side. You try to avoid polishing too peripheral and hitting the iris. I try to avoid doing that whenever possible. Widening the incision with the blade here. Again, any really dense lens, any cases in that regard, I like to use 3-piece lenses. Those tend to have weaker zonules. So this is a 3-piece lens. The bevel's pointed towards the left. The leading haptic goes into the bag. Rotate my wrist. The optic comes out planar. And then using the Maltzman to dial the trailing haptic into the bag. Go in with irrigation off, activate irrigation, and then going underneath the lens, removing the viscoelastic from within the bag, repositing the optic back down, just rotating the lens a little bit, polishing, and then switching to visco mode, removing all the viscoelastic from the anterior chamber, and then I'll hydrate my incisions. You can see as I'm pushing the BSS, the stria lines in the posterior capsule, they always tend to be in the same direction of the haptics. And this does suggest some zonular laxity. This again showed terminal chop and then cross chop techniques. Again, the CDE 7.39. This patient will have a clearer cornea postoperatively relative to other techniques. Again, this has been my experience. My partner has also adopted this technique, and he also advocates and agrees with me. And I've had many of you all contact me and essentially validate everything that I've been saying. And so I love terminal chop because you do debulk the center, and then you're able to fracture from the terminal side, which propagates a deep fracture that goes all the way down to the deepest lens layers. And so this really avoids you getting a posterior plate phenomenon. But then once you crack it all the way through, you do have some extra space, which is nice. And then I perform multiple cross chop maneuvers, getting the chopper around the lens, crushing it against the phaco tip, and doing this over and over and over again. And as a result, this patient did very, very well and had clear corneas postoperatively, and the patient was happy. So I hope this was helpful to you, and I thank you for your attention.